The BATC's most prestigious award is the Grant Dixon Award for Innovation. How many years have you been on this project, Charles?
4.
4 years, and this has been conducted over here to the US.
Yeah.
Just US or Canada? Just US?
No, just the US.
And there's 4 people involved here, but Charles is the one who's going to receive the award. So this is the award to the DATVExpress, and it goes to Art, WA8RMC, Charles here, G4GUO, Tom Gould, WB6P, and Ken, W6HHC. So would you like to receive this award on our behalf for all the effort that you've made?
Yes, certainly. Thank you very much. Most unexpected.
Well done.
Thank you.
We appreciate all your effort.
Now I can do the talk.
Yes.
I was expecting... Yeah, right.
We ought to have it standing up behind you.
Okay, sure.
There we go. Right. You got the clicker?
No, I haven't got the clicker. Right, you just... Was it... that one, right, okay.
Well, whichever way. Yeah.
Okay, fine, right, okay. Well, that's me. Oh.
Technology.
No, it's all right. You pointed the wrong button to me. The DATVExpress team is Ken, W6HHC, who is the program manager. Art, W8RMC, who's the hardware design. Tom, who is the PCB designer. Myself, and of course you, because if you don't buy the thing, it's not worth us doing it. So you're probably the most important part of the whole project. This is just a quick overview of what the project is, because I should imagine you're getting tired, sick to death of hearing about it now. It was designed as a DVB-S transmitter, and it consists of 3 components: the Linux PC, capture device, DATVExpress itself, and it uses DATVExpress is basically a USB peripheral board comprising 65 to 2.5 gigahertz IQ modulator with an FPGA to do the filtering. The actual manufacturer specifies 72 to 2.4 gig range than that. So it should be fine if you want to use it for the uplink for this new satellite that we hope comes about. Its maximum transmit band got 2 5 megahertz low-pass anti-alias filters in there, and at the moment it supports DVB-S2 and DVB-T in an SDR mode. It wasn't originally designed to do that, but people seem to be interested in that, and I've actually put all the source code for this on GitHub, and I've already had someone port the DVB-S2 onto GNU Radio, and they've added some of the DVB-S2 extensions which came out about 3 months ago. One of those extensions, I don't know whether he's implemented it, is carrier ID. So they were having problems with OB units that were using S2 jamming one another, and they couldn't identify who the various carriers were. Now they encode the carrier in the transmission. I haven't actually read the spec myself, because you can't get any receiver chips for it at consumer prices yet. So I thought, well, until they come along, I won't implement it. I've got other things to do. This is the board itself. I'm now trying to find where the button to operate the laser. Sorry? Near the top. No. No. Sorry?
just that one there.
Oh, right, okay.
Green one.
A quick overview of what's on the board. That's the USB 2 connector. That's the 48 meg oscillator for the Cypress semiconductor USB 2 controller chip. That's some flash memory which actually is just used to change the USB VID and PID addresses. And those are actually some RS-232 connectors. We don't use them, but they're in the chip, so I got the hardware guy in the final thing to add those. He's rather overdone it. I didn't really want holes that big, but never mind. That's the FPGA. That's some of the spare I/O from the FPGA. We haven't decided what to do with that yet. That's a dual channel A to D converter, which the eventual plan is to use that to connect to a VSWR on the output. So if you unplug the aerial or something, the DATVExpress can know what you've done and switch the transmitter off, but we haven't got round to that yet. There's our D2A converter. It's a dual channel 14-bit D2A converter, and as Brian was saying, it's got a balanced output which goes into a balanced filter, and then that goes into the modulator stroke PLL chip, so that does all the magic. I can't quite see where. Oh, there's the crystal reference oscillator for that. It's a 20 meg oscillator, but you could remove it and hook up a GPS if you want, a GPS source if you wanted to. There's the MMIC output, because Art was a bit worried about people blowing it up, so he put a 3 dB pad on there. I must admit, I think those things probably won't blow up even if the pad's missing. And all the power supplies are up here. Obviously, there's the input. We had to add an extra inductor on the power supply because we were getting switching noise from here. Was modulating the output of the MMIC, and we were getting 1.3 megahertz sprogs on either side. But just showing one inductor in there got rid of them almost completely. You can hardly notice them now. Unfortunately, shortly after we got those inductors, they became obsolete. So, but I think Art's he's done a one-off purchase of as many as we'll ever need. So we'll hope. Right. I think they call them fiducials, and it tells the machine that puts the components on the board where exactly the board is located. We had a slight problem with those. On some of the boards, they'd over-etched them, so the boards had to be rejected. All right, can't seem to change the thing now. I noticed when I was pressing the laser it was getting weaker.
Perhaps we do that.
Yeah.
Oh dear.
Use the manual system.
Yeah, I know. This are you using OpenOffice or?
Yeah, is there a video?
Yeah, there was a video.
You only sent me the PowerPoint.
Oh, did I? Oh, I thought I sent the whole thing, but never mind. All right, next one. That was just the machine making it, just go putting all the components on.
We'll show Kevin's again that we showed yesterday.
You have to use the. Oh right, okay.
Speeded up KLB working.
Right, audio and video capture. We're doing the same as with Digilight. We're using their Halpage devices. We've come across a problem now with the Halpage. The USB devices, they've come out with a new one, and currently the Linux support is, I wouldn't say non-existent, it's not in the latest kernels or kernel modules. We've had to sign an NDA to get hold of it, they're pleased to work with us, and they will be releasing the new drivers for that. Well, they were supposed to be doing it in July. How it's going to get into the actual Linux distributions, I don't know. Now, the other thing I've been experimenting with recently is the analog, using an analog capture, an easy cap, instead of the Halpage, and using the AV codec libraries that come with Linux to do the compression. But that has its drawbacks, which I will come to in a moment. And we were also adding a UDP transport stream. It used to be in there, and I managed to improve it so it no longer worked. So, but I've got some design decisions to make over that. Whether I get it to just have the video and audio going in there, and DATVExpress works out all the SI tables, or whether I just say you've got to send a valid MPEG-2 stream to it, or a transport stream. That's to be decided, and it's why I haven't released it yet, because I'm still thinking about it. On the host, we use Qt4, which is a cross-platform development tool. It was originally developed by Nokia, and now it's owned by another company whose name I can never remember. And they've improved it to the state that it's much more difficult to use now. You used to be able just to install it, and you could compile stuff. Now when you install it, it asks you which compiler you want to use, what cross-platform you want to use, and it's a real pain to set up. But once it's set up, it works very well. And someone's done a Qt version for Windows. So in theory, you could get DATVExpress to work on Windows. The USB drivers for the chip we're using exist. The HPSDR project used them, or used to use them. They've now gone to Ethernet, so there you go. They no longer do that. Currently, we've had it running on an Intel-based platform, and we're also experimenting with ARM-based things. But we're hitting the same problems that Brian mentioned, in that audio support is lacking in a lot of these things, and it's a matter of finding ones that have got the right peripherals in there, or software modules to do the compression. So we're always on the hunt for a better widget. Where's it going? Well, the demand seems to be for portable operation, and becoming more and more popular, I believe, or so Art keeps telling me. They seem to work on the basis that you turn the power up until the MER starts to get worse, and then you back it back slightly, and you don't worry about any of the spectral regrowth. Of course, Ken and I have said, oh, you can't do that, and Art says, well, it works. So. As I said, Express was designed for DVB-S, but it will do DVB-T with limitations. The limitations are principally to do with the USB bandwidth. I think I mentioned that later in a later slide. With an ARM host, we've only managed to be able to do about 2 megahertz DVB-T, and we'd like to get rid of the codec, but the hardware codec, and do it in software. There are libraries available for this. Unfortunately, the code that I've written uses the very latest version of the libraries, which is not in the current version of Linux. So I have to build my own version of the codec libraries, and then every time I do an upgrade, it deletes them and puts the ones that it wants in there, and I have to redo it again. I'm sure a clever Linux person could probably stop it doing that. Go. Right, video capture problems. There are multiple chipsets of the EasyCap. I think there's 5 in all. The most common one, which I think is the UT007 chipset, doesn't work under Linux. And I found that with eBay merchants, even if they say this uses such and such a chipset, you order one and it doesn't. It uses the cheap UTV 007 chipsets. And then when you say, well, you've sold me something you're not advertised, if you return it, we'll give you your money back, but you pay the postage, which is in the terms and conditions. And then you look on the eBay thing and they say it's got to be registered post or a courier service or something, and it works out more expensive to return it than so it just goes in the junk box. So I'm collecting all sorts of these things. The original one, which is, they've changed the name of it, it's EZ-CAT now, with a Z, because all the foreign or Chinese manufacturers were making clones of it, so EZ-CAT decided they'd change their name because it wasn't a registered trademark. The video works, but there's an issue with the audio. And it's funny really, because when you use the mixer with Linux, you can see the audio there, but if you use any other application with it, it doesn't work. I mean, I thought, well, it's my crap software, but I've actually used VLC and exactly the same thing happens. And when you actually look at the vids and PIDs, you find that the ones that they're using on their hardware are in fact the development vid PIDs. They really shouldn't be using that. They should be using their own ones. So I suspect that is what's behind the problems with the audio, because it just can't identify what it's doing, what chip it's got. Also, when I do the analog stuff with the Halpage, if you plug NTSC or whatever in it, it works out what you've put in and it sets it up appropriately. I've got to do this all manually, so because obviously we're selling these things to the Americans and they don't use PAL, so that's just extra software to work. And the other issue is that because the audio doesn't work, I've been using a separate audio on a PC, and of course the clocks and they come from different clock sources, so you've got the same problem with the synchronization on that. Right, the next thing is the MPEG-2 requires YUV 420p input format to it, and of course the EZ-CAPs don't support YUV 420. They've got, the closest one that I could find was YUYV 422p, so I have to do a software conversion so it's in the format. I've done some experiments with the Odroid U3 Plus, and I managed to transmit 2 meg DVB-T and do the video and audio compression in software. So it is possible to do that. That's just using the Neon SIMD instruction set. It's nothing particularly clever. Right, obviously when you're doing software it uses more CPU. I've already mentioned the YUV problem. The other thing is that every variant of the ARM device seems to be different. They use different code processors, accelerators and what have you. It's a minefield really, and you've got to do an awful lot of reading, and I still haven't come across the ideal device for this. Another thing I've found is it's best to get a properly supported Linux distribution rather than someone's weekend project, because the MK808 stuff, the guy that did that, one, he didn't really know how to do the hardware, the hardware encoding side of things, and secondly, the 802 came out and he's lost interest in the 808 and has moved on to that. So you've got a partially supported, well, unsupported Linux distribution. So that's a recipe for the disaster. Now, Odroid 3 Plus has been mentioned. This is what it looks like. It's got a heatsink on it. But I bought the fan power that goes on the top of that, but it makes the thing quite large, so I didn't bother with that. But it's very small. It's about the same size as a Raspberry Pi, and it's a quad core, and I think it runs at about 1.7 gigahertz. It scales up depending on what you're doing, so it's got power saving modes. But I just thought you'd like to see what they look like.